You know what light is? Light is a type of electromagnetic waves, and it is a transverse wave, and it travels in a straight line. This is what we already know about light. In the same way, we know some objects which have light of their own. We call them illuminated object, like a bulb, sun. Okay, moon is not an illuminated object because it reflects the light which falls on it from the sun. Okay, so we see the things because of reflection. Light from an illuminated object like sun in this case falls on the object, here tree, and tree reflects light which enters our eyes and we see the tree. In the same way, all the things around us, people around us, walls, and every object we see because of the light and reflection. So here, mirror is a surface which reflects maximum amount of light. So here, beam of light is striking the mirror and it is reflected. A mirror is a polished surface which reflects light well. A ray which strikes the mirror is called incident ray. The ray which bounces off is called reflected ray. The point on the mirror where ray strikes is called point of incidence. Normal is a line which is drawn at 90 degrees to the surface of mirror at the point of incidence. The angle between reflected ray and the normal is called angle of reflection. And angle of incidence is equal to angle of reflection. And angle between incident ray and the normal is called angle of incidence. Here, there are a few diagrams shown regarding reflection of light. You can see incident ray striking the surface of the mirror. Normal is drawn at the point of incidence. And this is the reflected ray. I, angle of incidence. R, angle of reflection. I is equal to R. Okay, there is another diagram for the same topic. Here on the surface of the mirror, incident ray, reflected ray. Third diagram, normal is already drawn here. Surface of the mirror is shown. Usually when we draw in our notebooks, we draw mirror like this. Okay, so mirror is a perfectly polished surface. Here this ray is striking at greater angle. Angle of incidence is greater, so angle of reflection is also greater. And here again, the ray of light which strikes the mirror at 90 degrees comes back following the same path. See, the blue color here shows the light going towards the mirror. It is striking at an angle of 90 degrees with the surface. We can say that it is coming along the normal. In the same way, this ray reflects off following the same path. Here, image formation by plane mirror. So here this is an incident ray. Incident ray from the candle, it goes towards this. Then what do? We first draw the normal at the point of incidence. We measure angle of incidence, and this is angle of reflected ray entering our eye. So how can we locate the image? We have to know the image distance is equal to object distance. It means object, the distance, whatever is it, the image forms far behind the mirror as far object is in front of it. So we measure this distance and we measure the distance behind the mirror, okay, and locate a point. Okay, and this is an incident ray. So we get 2 points, one here and one here. So this is, we draw in dotted form, and this is the reflected ray. Here we have located the image first, okay, and we have drawn the rays later on. This is one method. Okay, draw one incident ray striking at 90 degrees and produce it back in a dotted line and take it up to the same distance behind the mirror as far object is in front of it. Like if it is 4 centimeter, then this is also 4 centimeter exactly in front of it. Okay. So then draw one incident ray, and you don't need to draw the normal. You have one point of incidence. There is another point here. So join these 2 points in dotted form because this is not the actual ray. It appears to be coming from here. And then continue in a thick line and take it towards the eye. So you can draw reflected. this way. Okay, so your diagram for reflection of light and image formation is drawn here. There is another method. And how do we draw the rays? Let us see. This is a mirror shown. This is an incident ray. This is a normal. Of course, we need to have a protractor to measure the angle of incidence. So this is the protractor. You measure the angle of incidence. It is in this case, you consider 90 as 0. So 10, 20, 30, and almost 35 this is. So it means reflected ray will also be drawn at 35. Okay, so this is how we place the mirror. We 90 shows the position of normal, and we consider it as 0 and start counting this way. 90 is 0, then 100 is 10, 110 is 20, 30, and it is lying between 120 and 130 means 30 and 40. So it is 35 almost. Okay. Now we will draw reflected ray at the same angle. Okay, this is how we can draw, and we measure the angle. We mark angle of incidence here and angle of reflection here. There is another method of drawing the ray diagram and locating image. Here you don't need to mark the image position by measuring object distance here from the mirror. You need to draw number one, two incident rays. This is a different method. One incident ray at any angle you draw, and another incident ray at different angle, and then draw two normal for each incident rays. Okay, this is normal 1 and this is normal 2. Measure angle of incidence for this one, angle of in the incidence for the other ray, blue ray. Now draw same reflected angle for both the rays. Now extend these, then draw reflected rays, produce them back in the point where they uh, like coincide or intersect each other will be the point of incidence, the point of image. Here these are the characteristics. Image size is same as that of object size. Far behind, image is laterally inverted, right becomes left, left becomes right. Image is virtual. This is rotation of plane mirror. Rotation of plane mirror means what happens when the mirror is rotated through an angle theta. So first, this is the first position, Mn, original position of the mirror. This is incident ray and this is reflected ray. Suppose the angle is 40 and 40 in this case, both the angles are 40. Okay. Now, after doing this, this is the normal at the point of incidence P. We have to rotate up to 10 degrees. It means you have to keep the protractor here, mark position of 10 degrees here, then turn the protractor down, mark 10 degrees on this side also, and join these 2 points. Passing through the point P, you will get the new position of mirror. Okay, this is new position. This is completed in the next diagram. Of course, when the mirror position is changed, normal will also shift. So here, this is old normal in black color on the mirror Mn. Now M dash, N dash is the new position of the mirror. So normal in red line is shown for this. Incident ray is the same. So what is the angle of incidence now with respect to new normal? It is 40 plus 10 means 50 degrees. Okay. So now, of course, with this angle of incidence, we will have new angle reflected ray. This one. This is 50. So this with respect to this normal also, this is 50. Okay, reflected ray 2 in green color is shown. Okay, reflected ray 1, it means when the mirror is rotated, the reflected ray also shifts. It means image will also rotate. Image size will not change. It will remain the same, only its position will change. Okay, it will also rotate by that angle. How much will be this angle? You measure it, you will find that it is 20 degrees. Okay, we rotate the mirror 10 degrees. So reflected ray 1 and reflected ray 2, they have angle twice the angle through which mirror is rotated. That means 20 degrees. Here, this is more clear diagram. Okay, first normal is removed from it, 50-degree angle of incidence, 50-degree angle of reflection, and angle between incident ray, reflected ray 1 and reflected ray 2 is 20 degrees. Now two plane mirrors at 90 degrees. What happens when two plane mirrors are 90 degrees? This perpendicular mirror. Okay, this is a coin. You can see three images. 1, 2, 3. Suppose this is your mirror M1 and mirror image of this mirror M1 is shown in the mirror M2 also. In the same way, image of mirror M2 is shown in mirror M1. It means this coin, image of the coin, formed in mirror M1 is formed in the combined mirror here. Okay, in the same way, this is the image of this also. So these two now behave like object for this image. So how do we draw incident rays here? This is incident ray striking the mirror. This is the normal. It is at 45 degrees, so it will reflect at 45 degrees. Now it strikes the mirror M2. Again 45. So normal this way and this goes this way. AB incident ray, BC reflected ray for mirror M1, but incident ray for mirror M2, and CD is reflected ray. Here there is another diagram shown. How do we see the image formed by two mirrors? M1 and M2 are two perpendicular mirrors. This is an object. Two rays from the object are drawn towards the mirror M2. You could have done it from the mirror M1 also. Okay, so this is reflected. You will have to draw the normal to draw it properly so that the angles are same. So now if you you'd have to know the distance of the object. Suppose this is 2 centimeter, so this will also be 2 centimeter. Okay, behind the mirror. Now reflected ray, you will keep the ruler here. This is the point again. So join this point and extend till it goes and strikes the other mirror. Okay, second ray is also drawn this way. This is the point and this point. Join this and then take it towards the second mirror. Now we have got, these are the two reflected ray for mirror 2, but these are the incident ray for mirror 1. Now this image which is formed in mirror M2, we call it image 2. This serves as an object for mirror which will be formed here. Okay, so this distance from here will be same as the distance of this. It means you can extend the mirror position this way. So this distance and this distance will be the same. Now start from this, and we have already two incident points here. So two rays are drawn this way. Start from here and join these two lines in dotted one because these are not the real rays, and then in thick lines. Okay, and this will be again, this is the point and this point. Join them in dotted form and extend and take it towards the eye. So this is, so we can see three images here. Maximum three images can be seen when two mirrors are perpendicular to each other. But sometimes we can see two also depending on where eye is placed. Depending on the position of eye, two or three images can be seen. Okay, and when the mirrors are perpendicular, see these object and three images, they form a rectangle. Mirrors parallel to each other. So this forms so many images. This is an object placed between the two mirrors. So object distance, image distance, same. So this is first one, image 1. This will serve as an object for mirror 2. So you have to measure it from here. From the second mirror, this distance will be equal to this. Okay, so we have so many. And I2. I2 is what? I2 is the image formed by mirror 2 of this object. I1 of this the same object, I1 in mirror M1 and I2 in mirror M2. Okay, now this I1 serves as another object for mirror 2. So total distance is this, and this is the image I12. I12 is the image which is formed due to this object. This is like an object for mirror M2. So what is the distance? Greater distance now. From mirror to what is distance of I1, which is serving like an object. So this distance is greater now. So at the same distance, I12 will be formed. Okay. Now this I2 will serve as an object for mirror M1. So this distance from the mirror is same as the distance of I21 from the mirror. Okay, I21 is the image of this object. This is actually image, but this is acting like an object for mirror M1. So we see multiple images. Okay, that you need to know so many images. It will go on. Here only 3 and 3 are shown, but you can see that this will be serving as an object for this one, this will be serving as an object for the mirror 2. So we will see number of images. Okay, just you need to know little knowledge of it. Regular and diffuse reflection. Regular reflection occurs when reflected ray of light, it falls on a smooth surface, okay, very smooth surface, and form a clear image. And diffuse reflection occurs when the ray light reflects off a rough surface and forms a blurry image and no image at all. This is simple one ray. There are parallel rays striking the mirror and they are reflecting. You can see one thing. Incident rays are parallel to each other, reflected rays are also parallel to each other on a smooth surface. But what happens when the rays of light, they strike rough surface? Then incident rays are parallel, but reflected rays are not parallel. They go in different direction. What is the reason? We call it diffuse reflection. What is the reason? Let us have a look at it. This is specular or regular reflection, and this is diffuse reflection, rough surface. See here, ray A strikes this surface. Normal is vertical at this point. So red A dash is the reflected ray. Now the ray B is striking the surface this way. So normal is different now. Normals are not parallel. Okay, normal is not this way. Normal has to be 90-degree on the surface at the point of incidence. So the surface is inclined this way. So normal is now directed in this way. Okay, so reflected ray will follow the laws of reflection. Angle of incidence will be equal to angle of reflection. So here for this incidence ray B, reflected ray goes this way. Now let us see reflected ray C. This is C. Now the surface is inclined this way. So normal will be 90-degree to this. So obeying the laws of reflection, angle of incidence will be equal to angle of reflection. So the ray goes and C has gone somewhere which is not seen here. Let's see, read D. For D, this is the normal. So the ray goes this way. For E, this is the normal and ray goes this way. So that is why, since the normals are not parallel, reflected rays are also not parallel to each other. There is explanation. For each type of reflection, each individual ray follows the laws of reflection. However, the roughness of the material means that each individual ray meets a surface which has a different orientation. The normal line at the point of incidence is different for different rays. Subsequently, when the individual rays reflect off the rough surface, according to the law of reflection, that is, angle of incidence is equal to angle of reflection, they scatter in different directions. The result is that the rays of light are incident upon the surface in a concentrated bundle and are diffused upon reflection. The diagrams it's not below, it is in the previous page. Okay, so it shows 5 incident rays were shown, in which I've just explained. Now, applications of specular and diffuse reflection. There are several interesting applications of this distinction between specular and diffuse reflection. Regular reflection is also called specular reflection. One application pertains to the relative difficulty of night driving on a wet asphalt roadway compared to a dry asphalt roadway. Most drivers are aware of the fact that driving at night on a wet roadway results in an annoying glare from oncoming headlights. The glare is the result of the specular reflection of the beam of light from an oncoming car. Normally, a roadway would cause diffuse reflection due to its rough surface. But if the surface is wet, water can fill the gaps and depressions and smooth out the surface. So rays of the light from the beam of an oncoming car hit the smooth surface, undergo specular reflection, and remain concentrated in a beam. Strike like a beam, strike the road like a beam, and reflect also like a beam. The driver perceives an annoying glare caused by this concentrated beam of reflected light. So it means diffuse reflection also has a uses. So it means we don't see the glare. In the same way, we can see the light before the sun rises and before after the sunset. That is also because of the diffuse reflection. Now there are two questions. You just have to check the understanding. If a bundle of parallel incident rays undergoing diffuse reflection follow the laws of reflection, then why do they scatter in many different directions after reflecting off a surface? Now, perhaps you have observed magazines which have glossy pages. The usual microscopically rough surface of the page has been filled in with a glossy substance to give the page of a magazine a smooth surface. Do you suppose that it would be easier to read from rough pages or glossy pages? Explain your answer. Let us see if you have answered. Each individual ray strikes the surface which has a different orientation. Okay, the answer is there, and I explained also. Since the normal is different for each ray, so direction of reflected ray will also be different. And it is much easier to read from the rough page because again the smooth page will cause glare. Okay, light will strike the page like a beam and it reflect also like a concentrated beam, and unwanted glare will be produced. So we like reading on the page which is rough. Okay, in the same way, there are some other applications. Those who have rough skin, they apply some creams. So creams will smooth out the roughness of the skin of the person. Okay, and that gives the effect that the person's face is having glow. Okay. Now, periscope, an application of the plane mirror. Periscope consists of two plane mirrors held at 45 degrees to each other. So here the boy can see the tree outside the wall. So he's sitting in his room and he has kept these two mirrors in a box, and these are held at 45 degrees to each other. Light ray from this strike the mirror, plane mirror M1, hits the mirror M2 and enters the person. Okay, though there is an obstacle with the eyes, without this instrument, boy could not see it. There is another application, submarine. People in submarine, which is under the water, can see any ship coming on the surface of water. Okay, so girls, watch this video carefully again and again. Note down the queries and anything which you want me to explain in the live class. Please let me know by writing your comments in the Google Classroom, and we will discuss it.